Thank you for your attendance. This is Hyunho from Gyeongil University. The title of my talk is focused on devising a privacy-preserving system named PrivBlock based on hybrid blockchain for remote healthcare. Introduction goes with a brief information on healthcare and analysis of related work. Then I will propose a new privacy-preserving system for healthcare, PrivBlock. Analysis is provided in the concern of security and privacy. Then I will conclude my talk. Let's start with some distinctive features of remote healthcare system. Remote healthcare system can monitor patient health status in real time. Patient can freely move without any constraints of time and place, which can save money and time. It can provide detailed healthcare services directly from doctor in charge to the patient. Healthcare system has various advantages, but it must provide security and privacy preserving on patient medical data. The medical data treatment is quite important issue in the healthcare system because the treated data are quite sensitive. Security consideration is the first step for the healthcare service. The remote healthcare service uses public network, so it must be secure against malicious attacks during data transmission, especially. And it also needs to be resistant against insider attacks. To cope with the problem, there are many researches with blockchain. The private blockchain allows only authorized users can access data in the blockchain, which could also provide data integrity. The core part of this talk is on the privacy. Medical data is quite sensitive, so privacy preserving is topmost important. There are two schemes to support privacy: anonymity and unlinkability. Pseudonymization would be applied to provide anonymity and unlinkability in the proposed system. It could make data not to be specified to any entity. There are three core related works for blockchain based on healthcare. First one is Healthcare System by Hashalia et al. It is based on a private blockchain which could provide privacy for patient health record. But it does not provide access control on the medical data, which is quite important for privacy preserving. Although authenticated users can have access to data, they should have any right to use the data. Another is a new medical data treatment based on public blockchain by Azaria et al. It could easily manage data using Ethereum, which provides easiness and scalability of medical data management. However, it could not provide access control also. Furthermore, it requires high computational overhead because system using proof of work or consensus that has high cost to construct the data structure. The other is a deep learning service based on private blockchain by Bhattacharya et al. Due to the private blockchain, usage ensures privacy and data consistency. But it could not provide scalability of the system. Also, it could not provide resistance against forward secrecy for system security. There are some common security and privacy problems in the previous related works. It is difficulty to patients to obtain their own data because their data are managed by the centralized hospital. They commonly are relying on the hospital's security and privacy for the patient data. Furthermore, patient accessibility to their data are limited. Thereby, we needed to devise a new solution to enhance patient right to self-determination and privacy preserving for patient medical data. From now on, I will talk on our proposal of a new blockchain-based healthcare system named PrivBlock. The goal of PrivBlock is to provide patient self-determination on their data and to preserving security and privacy. For them, the system uses a hybrid blockchain which combines public blockchain and private blockchain, a pseudonym mechanism, role-based access control, and delegation-based data access. This shows the configuration of the proposed PrivBlock. Blockchain as a data structure, access control, pseudonymization, and delegation. From now on, I will details on those components. The core part is the blockchain, which is composed of public and private. Public blockchain stores data that could be public to anyone. Next is the core part of PrivBlock data structure. Private blockchain, which is to keep privacy on the medical data. Furthermore, privacy mechanisms are applied before they are stored in the blockchain, which are pseudonymization and access control. It contains the medical data and provides its integrity to the data. It could provide data access right depending on their role in the system only. Each entity in the system has different accessibility depending on their role in the system. This could keep privacy of data clearly. Delegation-based method is necessary to special doctors from other hospitals so that they could access the only data for the patient in the special purpose only. However, they would be blocked after the finish of the usage time and purpose. Pseudonymization mechanism is adopted with data encryption for the privacy. We will provide two analyses, security and privacy. PrivBlock designed to provide security, privacy, and self-determination for healthcare system. To provide security, it is depending on access control and private blockchain. Privacy is supported by delegation, pseudonym, and private blockchain. Self-determination is upon delegation, access control, and private blockchain. The security goal of PrivBlock is to resist against insider attacks and provide for secrecy. Access control and private blockchain are prevent the information leakage. This figure shows that data encryption is applied to medical privacy data. Privacy preserving in PrivBlock could be achieved by pseudonymization, access control, and delegation to provide privacy. Figures show how to provide privacy preserving. Sovereignty is important for the healthcare services. PrivBlock keeps the medical data on private blockchain and uses access control to differentiate accessibility of data, depending on their role in the system. Figures show how to provide sovereignty of medical data in our system, PrivBlock. These tables summarize different features among related systems. Security is to limit the information leakage of healthcare data. Privacy is to preserve anonymity and untraceability of sensitive data. Sovereignty is provided by using access control with blockchain in PrivBlock. We need to focus again on the problems of the related systems. Harshalia et al. System could not provide access control in healthcare system. Algeria et al. System does not provide access control to the database. Furthermore, it requires big operation cost to consensus proof of work. Bhattacharya et al. System caused lack of scalability and also does not provide restricted access. Please check the features of PrivBlock. PrivBlock could provide all the required features for the medical healthcare services. There are several healthcare services, which has lack of security and privacy preserving, and most importantly, they do not provide patient data sovereignty. Medical information includes sensitive data, which need to provide privacy preserving and security support. This article divides the PrivBlock, which is privacy preserving hybrid blockchain for remote healthcare. PrivBlock uses blockchain as a data structure, access control to differentiate data access right, pseudonymization to hide sensitive data, and delegation to share and restrict data access from different organizations. Analysis showed that PrivBlock could be used as a solution for the security and privacy preserving for the different remote healthcare services. This is all of my talk. Thank you for your attendance.